All right. Good afternoon, all my viewers, my YouTube viewers. I have not done a video in a number of years. I've been very busy lately, but I do have some students who are asking me about some stuff, some simple Star Delta circuitry, and I just decide to give you guys what you asked for, even though I'm very busy. I'm gonna give you guys what you asked for. This is going out to my friend Bob in Africa, and along his fellow classmates who requested this video. It's just a simple Star Delta circuit with push buttons. I don't think I have any with push buttons on my YouTube channel, and so therefore he asked. So just try to follow as I go along here. I have my push buttons, the green, start, ready, stop. I have my main contactor right here. That's my Y contactor right here. This is my Delta contactor right here. My main contactor, my star contactor, and my Delta contactor. I have my thermal overload here, and I have my timer. This timer is multifunctional, can be used in many different applications, can control more than one pump. You can use it for Star Delta. I can use it to rotate, to shift pumps based on timing, meaning I could run one pump for a number of hours and shift from that to another pump and run it for the same amount of hours and start over all over again. So it has a wide range of functions. So let me just try to go to the circuitry. Let me just indicate that I use different color wires to indicate your negative from your positive, your live from your neutral, your hot from your zero potential. So we all know red is live or hot, and the blue wire is neutral, zero potential. Let me try to go over the wiring, or let me operate it first so you can see. Look carefully. These two contactors are going to slam in first, and after about 10 seconds delay time, this one's going to slam out and this one's going to energize. You have to look at this little particular device, that little particular indication there. This is an auxiliary on top of it. If you look carefully, it's an auxiliary. I put the overload on the Delta side because the main contactor and your Delta contactor, they're going to share the same phase currents. Alright? They're going to split the currents in two. So for instance, if you have 60, 65 line current, you're going to have about 34, 33 here and 34, 33 here. So they share the current, alright? So it doesn't matter where you put the overload, once it's on the main or the Delta contactor. Alright? Let me energize it. I'm here. Look carefully. Two are in. Now look carefully, you see. 10 seconds. Boom. So I'm operational, and because it's a push button, if power goes, it's not gonna automatically start again. So you'll have to come back and restart it. If you look at my timer, it's fully energized. Alright. Good. Fully energized. If I press the start button, it's gonna go off. Boom. So there's no power to the timer. Whenever I press the start button, it's gonna energize your main contactor along with your timer. Alright, whenever I press the start button, it's gonna de-energize the entire circuit. Alright? And that's the same thing what you need when you have a power outage. And when power returns and you go back to start the pump or the machinery, it starts in the proper configuration. Alright? Star, wait 10 seconds. Then you have Delta. And that's it. Boom. Now going through the circuitry. I have my 2 feed wires coming from that little socket over there. That 220 socket out there comes in. Let me start with the neutral so you understand. Your neutral comes right in. It goes to your overload. Normally, well, you don't put it to a fuse. It goes straight to your overload. All right. From your overload, I have to find the neutral to power the timer. So I power my timer neutral terminal from the 95 of your overload. All right. 95 of your overload. All right. So my timer has a neutral. And then for the contactors now, because in case the motor trips on overload, it shuts off the neutral for all the contactors, completely killing the circuit as well. So for the contactors now, I came out of 96, is this wire right here, and I loop to all the contactors. Simple. Come in right here, that's it. Loops to that one, loops over to that one, loops over to that one. And that's it. That's all my neutrals. Your neutrals are to pass through your overload. Alright? Your timer needs its own source. Alright? Your timer needs its own personal neutral. Alright? That's why it's here. That's why I have two wires here. Because between these two there's a normally closed auxiliary. When I press the button, it becomes open. When it trips, it opens. When the pump trips, it opens. Alright? Now going through my live. This is my feeding wire. Comes in to the start of my start button. And you realize I have two wires coming out the back side here. One wire is for the holding circuit. This wire here goes here, comes down, comes under here. See right there. And it's for the holding circuit. If you look carefully, it's in auxiliary. A normally open auxiliary to the bottom here. Comes out and it goes into the main contactor coil. So that's my holding circuit. That's the reason why this coil never slams out whenever the timer changes. Alright, it's configured directly from the start button for the holding circuit. And because it's push buttons, you're gonna need it. Alright? You're gonna need it for push buttons. You need a holding circuit to keep this contactor slammed in while the others change. Alright? So that's your holding circuit. Now the other wire, which is this one, goes to my start button. Alright? Comes out of my start button. From here. That's it. This. And I went to auxiliary. Alright, I went to an auxiliary. And I came out of the auxiliary and I just looped back to the coil. So the wire from your start button goes straight to your M coil. Alright, that started. The push button is gonna start it while the holding circuit keeps it energized. Alright? And then I came within a normally open auxiliary. I came out and I came down to my timer. And I came to the 15, to the coil of my timer, which is A1. And I took another wire from there and I came to the 15, which is the start of the normally closed contact. Alright? Good. A1 and you have 15 to the back of it. So both wires are energized from the start button. Alright? My timer coil along with the start of the normally closed auxiliary within the timer. Alright? So when I press the start button, power is going to pass through, power is going to go in to energize the coil to start the delay, while the other wire goes to 15 and attach down to 16 because it's normally closed, which is a closed contact. And this closed contact going through a normally open, a normally closed auxiliary on the Delta contactor for interlocking sake, or interlocking reasons, protection reasons. It comes out and it goes to my star. So when my main contactor slams in, it's going to send the power. This auxiliary, this normally open auxiliary becomes normally closed because it slams in. Alright? Sends power down to the coil to energize the coil, and it also sends power to the 15, which is connected to 16. Comes around and it sends power through the normally closed auxiliary on the delta contactor, comes out, and it goes to the contactor coil of the star. So that's how these two contactors start. Alright, now after a time delay of 10 seconds, this timer is gonna kick out the normally closed connection between 15 and 16, and it's gonna go to the normally open. It's gonna make the normally open, which is 18, become normally closed. So after 10 seconds, I'm gonna switch from 15 to 16, and I'm gonna go from 15 to 18, which comes straight up, which is here. This is not all good. So you see it is not, and it goes right up here, and it comes in to my delta contactor. All right. So that's the basic configuration. I think I did it. I think I did it clear enough. This is the simplest way I could do it for you. And to put in this little auxiliary just to let you know that the interlocks. I should have an interlock here as well, but I don't have an auxiliary. I should have one here for protection purposes. All right. The wire, this wire here that powers from 18 from the timer to the delta contactor should go through a normally closed interlock on the star. The reason why they're here is because of protection purposes. All right. So in case of any mishaps, the contactors don't get confused. All right. I'll go deeper into that if you ask me. As of now, I'll have to think about it good. I'm a little bit rough because I'm a little bit I'm a little bit shaky because we don't use these anymore. We use soft starters and we use VFDs here in my country, in the Caribbean, the island of Nevis. You know, but it's still good to refresh my memory on these. All right. But that's how it goes, and I hope I explained everything to you. Understand the two wires here. One is for the holding circuit. This one's for the holding circuit to keep the main contactor standing. All right. The other one is for the start button to start the main contactor. So one wire, this wire, it starts it, energizes it, and the other one keeps it energized. All right. The feed for your star contactor, your star M coil, it needs to pass through the normally closed contact in your timer. All right. And the feed for your delta contactor needs to pass through the normally open contact on your timer. All right. Let me try to see if I can show you. Look at it. You see? Awesome. Look at the R. You'll see 15 and 16 are closed. After a time delay, it's going to switch to 15 to 18. All right. And this is the timer that can be used both on DC voltage and AC voltage from 24 volts to 240. All right. Look at the type of it. See the settings. Look at the settings. 1 second, 10 seconds, 1 minute, 10 minutes. You have 1 hour, 10 hours, 100 hours. You have the power sensitivity, and you have the different settings at the bottom: ER, WS, WA, ES. There are different settings that you can use. You'll have to read the paper, and it'll tell you what application you could use it for. All right, but I'm using it for Star Delta at this moment. All right, good. So I hope I explained everything well to you guys. Let me try to do it again. I'm gonna incorporate the overload setting as well. So I'm gonna start it. Starting again. After about 10 seconds, because that's the only time limit I have. All right, 10 seconds. Switching. Boom. And that's your Star Delta starting with a push button system. Let me incorporate the overload. If it trips on overload, it shuts off the whole circuit. All right. And when I come back and I reset it, and I press start again, it starts back in the normal. It starts back the same. This is something you have to be very mindful of. All right. That you configure your timer in such a way that when power goes and comes back and you start it again, it does not start in full delta. It starts in star, then delta. There are some timers, if you don't wire them properly, they're gonna start back in full delta. So be very mindful of it. All right. I'm gonna stop, and I'm good. So I hope I explained it to you guys very well how you do it. If any questions, you ask me. Ask me very carefully. Ask me. Remember that for push button system, you need a holding circuit to keep the main contactor energized. Alright, this does not change unless you press the stop button. This contactor should not change. This should stay in from this feed, power that. After a time delay from your timer, that will trips out and this will slam in, being controlled by your timer. Alright? I hope I went through the wiring with you. Remember what I told you guys, alright? So you guys take care and be good. I'm here. So any questions, you feel free to ask me. I'll comment to you. If you need a diagram, I'll try my best to try it out for you. And to Bob and his classmates in Africa, I hope that this helps you. And to all my students over in India, in the wider areas, the Atlantic area, in England and all over, I hope I was able to explain the whole push button system to you. Thank you very much. Thank you for watching, and you guys take care. Be blessed.